Class example 1.52 asks us to determine both the graph and the equation for the inverse to this quadratic function. Now this example is like others we've done, so you'll likely want to try it on your own before clicking through the animations. Note that the original function is f of x equals x squared minus 9. This is a basic parabola that has been translated 9 units down. We'll first be asked to sketch the graph of the inverse on the same grid, and to make sure to indicate the transformed or corresponding points for each of the points highlighted with the dot. We know that the effect of an inverse is to map all points xy to yx. We see here that the inverse of our upright parabola is a sideways parabola. Notice that this graph will have invariant points, but none of them were the points that we plotted here. To identify the invariant points, it is easiest to draw the line y equals x. This is because invariant points for an inverse will always lie where the point has the same x and y coordinate. Here we see 1 in quadrant 3 and 1 in quadrant 1. Our original parabola, the one in blue, had a domain extending from negative infinity to positive infinity. Its range went as low as negative 9, the height of the vertex, and up to positive infinity. As we know, inverse relations will change the domain to the range and the range to the domain, because all things x and y are being exchanged. So we confirm with our green graph that the domain is from negative 9 to positive infinity, and that its range extends to negative infinity and to positive infinity. In order to determine the equation for the inverse in terms of x, we will first exchange x and y, and then we will isolate y. It is important to remember to include both the positive and negative square root here. If we forget the negative square root, then our inverse will be represented by only half of a parabola, specifically the top arm, so all things above the x-axis. Here, by including the plus and minus, we have graphed a relation which is not a function, but is the inverse of the original parabola.